Let's get some practice solving equations that involve fractions and decimals. And this equation clearly involves fractions. So let's see, we have negative 1/3 is equal to j over 4 minus 10 over 3. So I encourage you to pause the video and see if you could solve for j. What j would make this equation true? All right, now let's work through this together. So what I like to do is I like to isolate the variable that I'm trying to solve for on one side. And since it's already on the right-hand side, let's try to get all the things that involve j on the right-hand side and then get rid of everything else on the right-hand side. So I want to get rid of this negative 10/3, and the best way I can think of doing that is by adding 10/3. Now I can't just do that to one side of the equation, then it wouldn't be equal anymore. If this is equal to that, in order for the equality to be true, whatever I do to this, I have to do to that as well. So I have to add 10/3 to both sides. I have to add 10/3 to both sides of the equation. And so what am I going to get? On the left-hand side, I'm going to have negative 1/3 plus 10/3, which is 9/3, and then that's going to be equal to, and on the right-hand side, the negative 10/3 and the positive 10/3, those cancel out to just 0, and I'm just left with j over 4. It's equal to j over 4. Now you might recognize 9 over 3, that's the same thing as 9 divided by 3. So this is just going to be 3. So that simplifies it a little bit. 3, let me just rewrite it so you don't get confused. 3 is equal to j over 4. Now to solve for j, I could just multiply both sides by 4, because if I divide something by 4 and then multiply by 4, I'm just going to be left with that something. If I start with j and I divide by 4 and then I multiply, by 4, so I'm just going to multiply by 4, then I'm just going to be left with j on the right-hand side. But I can't just multiply the right-hand side by 4, I have to do it to the left-hand side as well. So I'll multiply the left-hand side by 4 as well. And what I will be left with, 4 times 3 is 12. And then j divided by 4 times 4, well, that's just going to be j. So we get j is equal to 12. And the neat thing about equations is you can verify that you indeed got the right answer. You can substitute 12 for j here and verify that negative 1/3 is equal to 12 over 4 minus 10/3. Does this actually work out? Well, 12 over 4 is the same thing as 3. And if I wanted to write that as thirds, this is the same thing as 9/3. And 9/3 minus 10/3 is indeed equal to negative 1/3. So we feel very good about that. Let's do another example. So I have n over 5 plus 0.6 is equal to 2. So let's isolate the n, this term that involves n on the left-hand side. So let's get rid of this 0.6. So let's subtract 0.6 from the left-hand side, but I can't just do it from the left, I have to do it from both sides if I want the equality to hold true. So subtract 0.6. Now on the left-hand side, I'm just going to be left with n over 5. And on the right-hand side, 2 minus 0.6, that's going to be 1.4. And if you don't want to do this in your head, you could work this out separately. It's going to be 2.0 minus 0.6. You could say, oh, this is 20 tenths minus 6 tenths, which is going to be 14 tenths, which is that there. Or if you want to do it a little bit kind of the traditional method, you say, oh, I'm trying to subtract 6 from 0. Let me regroup. That's going to be a 10. I'm going to take from the ones place. If I take a 1 from the ones place, then that's going to be equal to 10 tenths. 10 tenths minus 6 tenths is 4 tenths. And then bring down 1 minus 0 ones is just 1. So it's 1.4. And now, to solve for n, on the left I have n being divided by 5. If I just want an n here, I could just multiply by 5. So if I multiply by 5, 5 times n divided by 5 is going to be just n. But I can't just multiply the left-hand side by 5. I have to multiply the right-hand side by 5 as well. And so what is that going to get us? We are going to get n is equal to 1.4 times 5. 1.4 times 5. Now you might be able to do this in your head because this is 1 2/5, so this thing should all be equal to 7, but I'll just do it this way as well. 5 times 4 is 20. Regroup the 2. 1 times 5 is 5, plus 2 is 7. And when I look at all the numbers that I'm multiplying, I have one digit to the right of the decimal point, so my answer will have one digit to the right of the decimal point. So it's 7.0, or just 7. N is equal to 7. And you can verify that this works because 7 divided by 5 is going to be equal to 1.4 plus 0.6 is equal to 2. Let's do one more example. This is too much fun. All right, 0.5 times the whole quantity r plus 2.75 is equal to 3. And there's a bunch of ways that you could tackle this. A lot of times when you see something like this, your temptation might be, let's distribute the 0.5. But that makes it a little bit hairy, because 0.5 times 2.75, you can calculate that, and you will get the right answer if you do it correctly. But a simpler thing might be, well, let's just divide both sides by 0.5. That way I'm going to get more whole numbers involved. So if I divide, remember, whatever I do to the left-hand side, I have to do to the right-hand side. And the way my brain thought about it is, well, if I divide by 0.5 on the left-hand side, I could get rid of this. And if I divide by 0.5 on the right-hand side, I'm still going to get an integer. 3 divided by 0.5 is 6. It's the same thing as 3 divided by a half. How many halves fit into 3? 6 halves fit into 3. So this is going to be 6 right over here. So these cancel out, and then this is going to be equal to 6. So the whole thing is simplified now to r plus 2.75 is going to be equal to 6. And now to just isolate the r on the left-hand side, I could subtract the 2.75 from the left, but like we've seen multiple times, I can't just do it from the left. My brain is malfunctioning. 2.75. I can't just do it from the left, I have to do it from the right as well. 2.75. So this simplifies to r. This simplifies to r is equal to, what's 6 minus 2.75? Well, if you want to do it in your head, 6 minus 2 would be 4. And then if you take 0.75 from that, it would be 3.25. If you don't feel comfortable doing it in your head, we could just write it out. 6.00 minus 2.75. Be careful to align the decimals. And then I got to do some regrouping. Let's see, I have 0 hundredths trying to subtract 5 hundredths. That's not going to work out. So I try to regroup from here, but I have nothing here. So let me regroup from here. 1, 1. Let me take away one of these ones. So I'm going to have 5 ones, and then that's going to be equivalent. So I have 5 ones here, and that 1, 1 I took away is going to be 10 tenths. And then I could take one of those tenths away. So I'm going to have 9 tenths, and that's going to be 10 hundredths. And now I could subtract. 10 hundredths minus 5 hundredths is 5 hundredths. 9 tenths minus 7 tenths is 2 tenths. My decimal is going to be there. 5 minus 2 is 3. 3.25. And you can verify that. 3.25 plus 2.75 is 6 times 0.5 is indeed equal to 3. So we feel, once again, really good about this.